Hello, this is Mr. Molo for the lesson on geometric sequences. So kind of like arithmetic sequences, where it can only be plus or minus patterns, a geometric sequence can only be multiplication patterns. So kind of the same thing where we have to determine if it's a sequence first of all, and then instead of saying what the common difference is, it's called common ratio for geometric sequences. So if we see something like this, we go from 1 to 4 to 16 to 64, well, we can kind of see that we are going up. 4 divided by 1 is 4, 16 divided by 4 is 4, 64 divided by 4 is 4, or 64 divided by 16 is 4. All of them are going up by multiplying by 4. So yes, this would be geometric, and our difference is timesing by 4. And then they asked us to find the next 3 terms, so then we just keep multiplying by 4. So 64 times 4 is 256. 256 times 4 is 1024. 1024 times 4 is 4096. Kind of the same thing here. If you notice, this might be a little more difficult for us to remember. Like I said at the beginning, this is only a multiplying sequence. So a lot of you are saying, well, you're dividing by 3. Well, we can't say it's dividing by 3. We have to say it's a multiplying pattern. So you're really multiplying by a third. And in this case, you're multiplying by negative 1/3. So negative 9 times negative 1/3 is 3. 3 times negative 1/3 is 1. And so on with the positives and the negatives. Same thing here. You'll see we're going from positive, negative, positive, negative. Patterns hopefully a little easier for us to see. So 5 to 10, 10 to 20, 20 to 40. Again, if we divide those numbers, 10 divided by 5, 20 divided by 10, 40 divided by 20, it's all going to be 2. And since we're going positive, negative, we're multiplying by negative 2. And then just like arithmetic sequences, there's going to be a way to find out the nth term. And this is how we would find out the nth term for geometric sequences. So we still need to figure out what that first term is here. So there's still an a sub 1. Again, instead of finding the common difference, we're finding the common ratio. So we're going to need that r. There's still an n there, so the number we're looking for, and then minus 1. One thing to notice is this is to the exponent power. So it's not just times. You actually need to figure out what the power is there. So if I have a problem like this, so the first term in the geometric sequence is 500. The common ratio is 0.2. What is the 7th term of the sequence? So same thing, our first term is 500. So that's going to go there. Our ratio is 0.2, and then we're looking for the 7th term. So 7 minus 1 is 6. So we're not doing 0.2 times 6. We're doing 0.2 to the 6th power. So 0.2 times 0.2 times 0.2 times 0.2, 6 times. And then multiplying that by 500. And we end up with an answer that the 7th term would be 0.032. Let's find one that has some nicer numbers. So like this one, our first term is 5. We end up with the rate of 2, and then we're looking for the 6th term in the sequence. So that means we're starting at 5, we're multiplying by 2, and we're going to end up looking for the 6th term. So we have 6 minus 1 is 5, 2 to the 5th power, and then times 5. Let's actually write this one out so we can kind of see. So if we're starting with 5, and our common ratio is 2, that means we're timesing by 2. So 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. 40 times 2 is 80. 80 times 2 is 160. And this would be, there's the first term, there's the second term, there's the third term, there's the 4th term, there's the 5th term, and there it is. The 6th term is 160. Okay, so we could do it again the long way where we're multiplying it out every single time, or we could use this formula just to kind of figure out what it's going to look like. And again, they're going to give it to us different ways. Sometimes they'll give it to us in this where it's going to be you know, just listing the 8th term. Remember, the sequence That's our first term. So 1,000 would still be our first term. Or they might give it to us as a table. So we're talking about a ball bouncing. Again, there's still our first term, the first one that we were talking about, 300. So just be aware that that first term might be given to us a couple different ways.